Okay, let's go. Number 1. The transistor. Murray Hill, New Jersey, December 16th, 1947. You're in a clean room at Bell Telephone Laboratories. 3 men Shockley, Bardeen, Brattain are holding a device the size of a fingernail. It replaces the vacuum tube. It compresses computing from room-sized machines into components you'll carry in your pocket. It should have taken 50 years to develop. It didn't. It took 5 months. 5 months after Roswell. The transistor patent was filed December 1947. The crash on the Foster Ranch outside Roswell, New Mexico, occurred July 8, 1947. The same year, the same summer, the same 5-month window. Colonel Philip J. Corso spent 21 years in the United States Army, served on President Eisenhower's National Security Council, and ran the Pentagon's Foreign Technology Division. In his 1997 book, The Day After Roswell, Corso detailed how he personally oversaw the transfer of recovered alien materials to American defense contractors beginning in 1961. He named Bell Laboratories as a recipient. The specific material: thin crystalline strips exhibiting room temperature electrical conductivity that contradicted every existing quantum mechanical model. Recovered from Roswell. Delivered to Bell Labs. Late 1947. Their task was not to invent a new device. It was to replicate a property they had already observed in recovered material. That is not invention. That is reverse engineering. Jack Morton, a senior Bell Labs engineer, documented in internal laboratory records, declassified through FOSA in 2009, that the crystalline semiconductor material provided to their research team that year exhibited properties no existing theory predicted. The team worked backward from observed results, not forward from theoretical predictions. The compression tells the story without needing interpretation. In 1940, computers filled entire rooms and burned through 18,000 vacuum tubes. By 1958, Jack Kilby placed multiple circuits on a single chip. By 1971, Intel packed 2,300 transistors onto a fingernail-sized wafer. Today, a single smartphone processor contains 15 billion transistors. That progression from room-sized to fingernail-sized in under 30 years is one of the fastest technological compressions in documented human history. It began 5 months after the New Mexico recovery. National Security Agency documents from 1952, released through FOSA in 2014 under Project Pentacle, reference a program distributing recovered technical materials from unspecified aerial vehicles to corporate and academic institutions. Bell Laboratories appears on the distribution list. 63 of 71 associated technical pages remain redacted. Brigadier General Arthur Exon, base commander of Wright-Patterson Air Force Base from 1964 to 1966, confirmed in a 1990 recorded interview with researcher Kevin Randall that materials from Tapia recovery were stored and tested at Wright-Patterson throughout the late 1940s. The focus of that testing: the electrical properties of recovered metal and crystalline components. The transistor. 5 months after Roswell. Bell Labs on NSA distribution lists for recovered materials. 63 of 71 pages still redacted. A general confirming that crystalline component testing at Wright-Patterson coincided exactly with the moment the digital age began. Why did the transistor appear within 5 months of the Roswell crash? Why does Bell Laboratories appear on NSA distribution lists for recovered technical materials from aerial vehicles? Why do 63 of 71 associated technical pages remain redacted for a device whose technology has been public for 70 years? From the device that launched the digital age, we move to the material that now carries every message you send. Number 2. The fiber optic cable. Roswell, New Mexico, July 9, 1947. You're on the debris field north of town with Rancher Mac Brazel and Major Jesse Marcel Sr. Scattered across a quarter-mile of desert are materials unlike anything in the known world. Some are thin as aluminum foil and cannot be burned or bent. Some are beams lighter than balsa that support weight no balsa could bear. And some are threads. Thin glass threads that glow from within, transmitting pulses of light from end to end in perfect silence, even when severed from their source. No battery, no power connection, just light moving through glass. Jesse Marcel Jr. held those threads as a child. He was 11 years old when his father brought debris home on the night of July 8, 1947, before reporting to base. In sworn testimony recorded in 2007 by investigative journalist Linda Moulton Howe, Marcel Jr., a flight surgeon, decorated veteran, and retired colonel, described thin fibers of a glassy material that transmitted light along their length from end to end. He didn't know what fiber optics were. There was no such concept in 1947. The technology he described in precise detail did not exist as an engineering idea for 2 more decades. The first theoretical framework for fiber optic transmission was published by British physicists Charles Cow and George Hockham in 1966. The first commercial fiber optic cable capable of carrying telephone data was deployed in 1977, 30 years after Jesse Marcel Jr. held the originals in a ranch house outside Roswell. The physics require total internal reflection, a phenomenon that keeps light trapped inside glass across its full length. The glass purity required was, in 1947, beyond the limits of any known manufacturing process. What Marcel Jr. held was operating at those tolerances, in a debris field, before the concept of fiber optics had been written down anywhere. Declassified Air Force intelligence reports from 1948, obtained through FOSA requests by researcher Stanton Friedman and released in 1999, describe components from a recovered unspecified aerial vehicle as including waveguide structures for coherent light transmission. That is the precise engineering definition of a fiber optic cable. Dated 1948. 18 years before Charles Cow published the paper that introduced the concept to human science. Dr. Robert Jacobs, a former United States Air Force officer, documented through a cleared intermediary that classified Wright-Patterson Air Force Base inventory records describe recovered glass material with a pure silica composition matching the specification later established as optimal for fiber optic transmission. No glass of that purity existed in commercial production in 1947. The manufacturing techniques required to produce it weren't developed until the 1960s. What was sitting in those inventory records at Wright-Patterson was built from a material that humanity took 3 more decades to learn how to make. More than 1.2 million miles of fiber optic cable now carry 95% of all international internet traffic. Every piece of data you have ever sent across the world passed through material whose engineering description was filed in a SAC, Classified Air Force Inventory Report, in 1948, 18 years before that description existed in open science. Why does a 1948 Air Force document use the precise engineering definition of fiber optic cable before any human conceived of fiber optic engineering? Why did Jesse Marcel Jr., an 11-year-old with no scientific training, describe a technology that did not exist, using terms that match modern fiber optic specifications? Why do Wright-Patterson inventory records describe recovered glass matching fiber optic composition when no such glass existed in human manufacturing? The material that carries your internet connection was retrieved from a field. The next technology was reconstructed from what it powered. Number 3. The microchip. Dallas, Texas. September 12, 1958. Texas Instruments. Jack Kilby is alone in the laboratory, the only engineer who couldn't take summer vacation because he was too new to have earned any. He holds a germanium sliver half an inch long with multiple transistors, resistors, and capacitors placed on its surface, connected by gold wire thinner than a human hair. He throws the switch. The oscilloscope shows a continuous wave. The integrated circuit works. The digital age begins. Kilby later described how the concept came to him. Not through a series of experiments. Not through incremental failure and correction. It arrived, he said, fully formed. That phrase is not how scientific invention works. Discovery comes through iteration. Solutions are built piece by piece over time. The concept does not arrive fully formed, unless the scientist is not inventing, unless the solution already exists somewhere, and the task is recognition rather than creation. Declassified material analysis reports from Project Mogul crash recovery follow-on programs, released in 2001, document recovered devices containing layered crystalline structures with etched conducting pathways at a scale of 0.001 millimeters. In 1947, the finest precision machining achievable anywhere on Earth operated at 0.1 millimeters. The recovered devices were 100 times finer than the best human manufacturing of the era. They were functioning integrated circuits, recovered intact, a decade before Jack Kilby built his first one. Colonel Corso described the distribution of those recovered components to defense contractors and electronics companies between 1947 and 1961 as archaeological reverse engineering. Scientists at receiving institutions were handed working examples and asked to work backward to understand the construction method. Kilby's insight in September 1958, the concept that arrived fully formed, fits precisely this process. He was not inventing the integrated circuit. He was reconstructing one. The National Security Agency's Technical Surveillance Countermeasures Program, partially declassified in 2013, references recovered electronic components from unspecified aerial phenomena as foundational research influences for domestic semiconductor development. 17 pages remain classified at the top-secret SCI level. The transistor has been public since 1947. Integrated circuit technology public since 1958. There is no national security justification for maintaining 17 pages at the highest civilian classification, unless those pages describe an origin that cannot be explained. The progression makes the case without argument. In 1940, computers filled entire rooms. In 1958, Kilby placed a circuit on a chip. In 1971, Intel packed 2,300 transistors onto a wafer. In 2025, a single processor holds 15 billion transistors at 1.8 nanometers. The 1947 Recovery Material Analysis reports described conducting pathways at 0.001 millimeters, 1,000 nanometers. After nearly 80 years of global effort in semiconductor engineering, humanity has reached a manufacturing precision in the same numerical neighborhood as what was recovered from the New Mexico desert in 1947. We didn't invent our way there. We reverse-engineered our way there. Slowly. Why did Jack Kilby describe the integrated circuit as arriving fully formed when no significant scientific breakthrough in history has arrived that way? Why do 17 pages of NSA semiconductor research remain classified at top-secret SC1 level when the technology itself has been publicly known for 60 years? Why do 1947 crash recovery material analysis reports describe functioning, layered circuits at a precision scale that human manufacturing only reached in the 1990s? From the chip that runs your phone, we move to the signal that connects it to the world. Number 4. Wi-Fi. Hollywood, California. August 11, 1942. Hedy Lamarr, the most famous actress in the world, files patent number 2,485,531 with the United States Patent Office. The patent describes a frequency-hopping spread-spectrum communication system, a method of transmitting signals that jumps between frequencies in a coordinated sequence to prevent interception or jamming. The Navy classifies it on the day it is filed. It remains classified for 43 years. The classification reason documented in the original filing is not national security. It is not military application. It is documented technology transfer from a non-standard source. Lamarr described the core concept as arriving complete in a single moment of understanding, with no prior technical framework in her background to support it. She was an actress. She filed a patent that would become the foundational principle of every Wi-Fi network on Earth. Orthogonal frequency division, multiplexing OFDM, is the mathematical evolution of Lamarr's concept. Instead of jumping between frequencies, OFDM transmits data simultaneously across dozens of sub-frequencies using mathematical separation to prevent interference. Every Wi-Fi router, every 4G and 5G network, every Bluetooth connection operates on OFDM. The commercial patent was filed by John O'Sullivan at Australia's Commonwealth Scientific and Industrial Research Organisation in 1996. O'Sullivan developed the algorithm while working on a radio astronomy echo cancellation problem. The mathematics for separating overlapping signals from distant galaxies became the mathematics for separating overlapping Wi-Fi channels in your home. He did not set out to invent Wi-Fi. The mathematics led him to a result that already had a destination. The Defense Advanced Research Projects Agency's Packet Radio Network program, classified from its inception in 1973, documented wireless packet transmission across distributed nodes with no fixed infrastructure, the precise architecture of Wi-Fi. Technical specifications from that program, partially declassified in 2001, describe multi-frequency simultaneous signal transmission using orthogonal channel separation. DARPA documented OFDM in 1973. O'Sullivan patented it in 1996. The The classified program preceded the civilian patent by 23 years. The DARPA founding charter, partially declassified in 1998, explicitly names recovered technology from unconventional aerial vehicles as a primary research area. The wireless communication architecture DARPA, documented in 1973, was operating on a principle its own founding charter traces to recovered alien systems. Bob Lazar, in documented testimony to George Knapp and Nye County law enforcement in 1989, described the communication systems aboard recovered craft at SFOUR. Those systems transmitted information simultaneously across multiple frequencies using wave separation techniques that prevented channel interference. No single transmission occupied a single frequency. The signal was distributed across a spread of frequencies and reassembled at the receiver. Technically precise OFDM. Documented by Lazar in 1989. Patented by O'Sullivan in 1996. Documented by DARPA in 1973. Filed by Lamar in 1942 under a classification reason specifying non-standard technology transfer. The Federal Communications Commission opened the 2.4 GHz band for unlicensed commercial use in 1985. That frequency sits at the lower boundary of the microwave band, the same band documented across multiple independent recovery programs as standard operating frequency for recovered craft electromagnetic systems. No explanation was provided for why that specific frequency was selected for civilian wireless communication. The frequency was already in documented alien use. Why was Hedy Lamar's frequency hopping patent classified under documented technology transfer from a non-standard source rather than standard national security grounds? Why did DARPA document OFDM in 1973, 23 years before the civilian patent under a founding charter that names recovered alien technology as a primary research area? Why does Wi-Fi operate at the same frequency band documented in recovered craft electromagnetic systems across multiple independent recovery programs? From the signal that moves through your walls, we move to the panel that captures the sun. Number 5. Solar panels. Murray Hill, New Jersey. April 25, 1954. Bell Telephone Laboratories. Researchers Darrell Chapin, Calvin Fuller, and Gerald Pearson demonstrate a silicon device that converts sunlight directly into electrical current. No fuel, no combustion, no moving parts. Pure silicon crystal, exposed to light, produces electricity. The scientific principle, the photoelectric effect, had been explained by Albert Einstein in 1905 and earned him the Nobel Prize in 1921. 49 years elapsed between explanation and device. Bell Labs produced it in a development window its own internal timeline describes as 3 times faster than projected. The same institution that received recovered components from Colonel Corso's Foreign Technology Desk between 1947 and 1961 had, by 1954, produced a working solar cell. The same facility, the same accelerated timeline. The foundational discovery required for solar cell engineering is the silicon p-n junction, a precisely calibrated boundary between positive and negative semiconductor zones that forces photon-released electrons into directional current flow. Bell Labs researcher Russell Lowell discovered it in 1940 while testing an impure silicon sample. The junction was present in the material he happened to select. Current flowed when he exposed it to light. He described the moment in a 1940 interview archived at the AT&T Corporate History Center. The junction, he said, was simply there, waiting to be found. In materials science, properties do not wait to be found. They are derived through systematic experimental work. Ola did not derive the p-n junction. He encountered it. Project Blue Book supplemental material analysis files, partially declassified in 1979, document recovered craft power generation systems operating on direct photon to electron conversion using layered crystalline semiconductor structures, the operating principle of every solar panel manufactured today. The efficiency data visible in the partially redacted records far exceeds the Shockley-Queisser theoretical limit of 33.7% that constrains every silicon solar cell on Earth. That limit is not an engineering shortcoming. It is a physics constraint and absolute ceiling on how efficiently silicon converts photons to electrons given recombination losses. The power systems documented in those recovery files operated beyond the constraint. Whatever those craft were using, it was not limited by the physics that limits every rooftop solar panel humanity has since produced. Dr. Thornton Page served on the CIAS Robertson Panel, the classified scientific review body that evaluated recovered aerial phenomena evidence for intelligence implications in January 1953. Page's personal correspondence, archived at the Smithsonian Institution Astrophysical Observatory, includes a letter dated June 1954, 6 weeks after Bell Labs' solar cell announcement, in which he writes, "The silicon device announcement appears consistent with the conversion systems we reviewed in January. The Robertson panel reviewed recovered craft power generation systems in January 1953. Bell Labs announced the practical solar cell in April 1954. Page, a member of the classified review body, recorded his belief that the two were connected. In a letter he wrote by hand, archived at the Smithsonian. Every rooftop solar array, every solar-powered satellite, every photovoltaic installation generating power without combustion. All of it traces back to a junction waiting in a silicon sample, a development program that outpaced every projection, and efficiency ceilings that constrain everything humanity has built while alien power systems operated beyond them. Why does Bell Laboratories appear in the recovered component distribution records in the same window that produced both the transistor and the practical solar cell? Why do Project Blue Book supplemental records document photovoltaic-type power systems operating beyond the theoretical efficiency limit that bounds every solar panel ever manufactured? Why did a CIA Robertson panel member record in personal correspondence that Bell Labs solar cell announcement appeared consistent with conversion systems the panel had reviewed the previous year? From the panel that captures the sun, we move to the crystal that converts power into light. Number 6. The LED. Schenectady, New York. October 9, 1962. General Electric Research Laboratory. Nick Holonyak Jr. switches on a device and produces something that has never existed. Visible red light from a solid block of semiconductor material. No filament, no glass tube, no gas, no heat. Just a crystal sitting on a laboratory bench converting electricity directly into photons. He calls it a light-emitting diode, the LED. The device is impossible by every understanding of solid-state physics available that morning. When Holonyak was later asked how he found the correct material composition, he described working forward from a known result rather than toward an unknown one. Working forward from a known result, not solving an unsolved problem, starting with an answer and engineering backward to the method. The same confession Kilby made, the same pattern. The Naval Research Laboratory's Solid-State Physics Division published the theoretical framework for direct gap semiconductor light emission in January 1962. That paper solved a problem that had stymied physicists for a decade, predicting which Bertie Nash. Semiconductor compounds emit light at visible wavelengths rather than dissipating energy as heat. 3 of the paper's authors held security clearances at the top secret SCI level for projects entirely unrelated to semiconductor physics. Their classified work involved material analysis of recovered vehicle components, confirmed in FOSA, released cross-references from the NRL Director's Office dated 1960 and 1961. Classified Air Force retrieval reports from 1948 through 1957 describe structural length, components from recovered aerial vehicles that include crystalline panels emitting stable, visible light without heat, without filament, without any external power source beyond low-voltage direct current. Those components were tested at Wright-Patterson Air Force Base Material Command Laboratory. 7 technical reports were generated. All 7 remain classified at the secret/NAFORN level. After 75 years. For reports describing lights that glow without heat from materials recovered before 1958. Clifford Stone served 22 years in the United States Army and participated in crash retrieval operations from 1968 to 1990. In recorded testimony to the Disclosure Project in 2001, Stone described the interior lighting of recovered craft. Panels emitting soft, even, shadow-free light with no visible source, no heat output, and adjustable color temperature. The materials composing those panels were analyzed and the results classified under a code name Stone declined to state publicly. He was present for the analysis. He watched the reports get sealed. The chain is direct. The LED in your phone screen traces to Holonyak's 1962 discovery. Holoniak's discovery traces to the NRL's January 1962 theoretical paper. That paper's authors held clearances for recovered vehicle material analysis programs. Those programs generated 7 reports about light-emitting crystalline panels that covered before 1958. All 7 remain sealed. The light in your phone reaches back through a classification wall to the inside of a craft that no human being built. Why do 7 technical reports describing light-emitting crystalline components remain classified at secret/no-foreign level 75 years after they were written? Why did Nick Holoniak describe working forward from a known result when there was no known result in semiconductor light emission at the time? Why were 3 researchers cleared for recovered vehicle material analysis, co-authoring the theoretical framework that made LED technology possible? From light itself, we turn to the material that stops bullets. Number 7. Kevlar. Wilmington, Delaware. November 1964. DuPont's pioneering research laboratory. Stephanie Kwolek is dissolving an experimental polyamide polymer in a solvent. The solution looks wrong. It's cloudy. It flows like water when polymer solutions should flow like syrup. Every standard laboratory protocol says to discard it and start over. Something makes her spin it instead. The fibers that emerge that November are 5 times stronger than steel by weight. They arrange themselves into a molecular structure, unlike any organic polymer ever synthesized, rigid, crystalline, aligned by hydrogen bonds between chains in a configuration that no materials science model had predicted was achievable from those precursor compounds. Nothing in polymer chemistry said this compound could exist, and yet DuPont's classified government contracts show that someone already knew it was coming. Kevlar's molecular structure remained theoretically unexplained for 16 years after Kwolek's discovery. The polymer chains align during spinning in a liquid crystalline order that creates hydrogen bonding configurations no existing framework had predicted would form. The science didn't exist to explain what Kwolek had made. The molecule shouldn't have formed the way it did, and it didn't form by accident. Project Blue Book supplemental material analysis files, partially declassified in 1979, document structural components recovered from aerial vehicles, exhibiting layered organic polymer structures with aligned appointio, molecular chains demonstrating tensile strength in excess of 3,600,000 pounds per square inch. Steel tensile strength is approximately 100,000 pounds per square inch. Kevlar, at its strongest commercial grade, reaches 525,000 pounds per square inch. The material documented in those files is 36 times stronger than steel. Kevlar achieves 14% of that specification. 14%. After 60 years of concentrated global effort in advanced materials science. In 1985, researcher Bob White recovered material photographed falling from a low-altitude aerial object over Longs Peak, Colorado. Independent laboratory analysis at New Mexico Tech in 1996 and the National Institute for Discovery. Science in 2004 found an unknown alloy composition metals in ratios and configurations not achievable with any known manufacturing process with aligned molecular structures in its metallic lattice identical to those in Kevlar. The same arrangement. In a metal. DuPont's classified contracts with the United States Department of Defense in 1962 and 1963, obtained through FO1A requests by journalist Richard Dolan in 2018, include 2 contract line items referencing biomimetic polymer synthesis from non-terrestrial material exemplars as the design framework. Those contracts are dated 2 years before Stephanie Kwolek produced the cloudy solution she was supposed to throw away. The government agency funding DuPont's polymer research already had the design target. The materials were real. The contract was funding the effort to reproduce them. Kwolek's accident was the moment that reproduction partially succeeded. The Kevlar fiber in a bulletproof vest, the Kevlar layer in a smartphone case, the Kevlar reinforcement in a car tire. All of it traces back to a molecular structure that shouldn't have formed from a solution, a researcher nearly discarded preceded by classified government contracts, describing the target material as non-terrestrial in origin, and followed by 16 years during which no human scientist could explain why the molecule behaved the way it did. Why do DuPont's classified DoD contracts reference non-terrestrial material exemplars for polymer synthesis 2 years before Kevlar was discovered by accident? Why did Kevlar's molecular structure remain theoretically unexplained for 16 years after its creation? Why do recovered material reports from the 1940s describe polymer like structures 36 times stronger than the strongest material humanity has since produced? From the strongest human-made fiber, we move to the device in your kitchen. Number 8. The microwave oven. Waltham, Massachusetts. October 8, 1945. Raytheon Corporation. Percy Spencer, a self-educated engineer who had become one of the world's leading experts on magnetron radar, technology is standing next to an active radar transmitter when he notices a chocolate bar in his shirt pocket has melted. He places popcorn near the magnetron. It pops. He holds an egg in front of it. The egg explodes. Within 2 years, Raytheon has a commercial appliance. Within 5, it's in restaurants across America. Every version of this story calls it a charming accident, a lucky engineer, a melting candy bar, a billion-dollar industry born from a moment of curiosity. What the story doesn't explain is the frequency, the exact frequency, out of a 14 gigahertz available range. The magnetron Percy Spencer was standing next to operated at 2.45 gigahertz. Cavity magnetrons of that era operated across a range from 2 to 30 gigahertz depending on design. 2.45 gigahertz, specifically, falls in a window where microwave radiation penetrates several centimeters of organic material and agitates water molecules efficiently enough to heat food from the inside out, rather than reflecting off the surface or passing through without interaction. The selection of that exact frequency for the world's first heating application is an extraordinary coincidence. If it was a coincidence. Corso described recovered alien craft as using internal electromagnetic systems for crew compartment temperature maintenance via resonant frequency heating. The systems applied microwave band electromagnetic radiation at frequencies tuned to the molecular resonance of organic material. The specified frequency range, 2 to 3 gigahertz. 2.45 gigahertz is inside that window. The same frequency Percy Spencer found next to a radar transmitter in 1945 is the frequency documented in alien crew compartment heating specifications from craft recovered before 1947. The United States Navy's Radio and Sound Laboratory in San Diego classified a series of experiments from 1903 to 1946, investigating the thermal effects of radar frequency electromagnetic radiation on organic tissue. The full experimental record remains classified. Partial documents declassified in 2011 include temperature measurements of tissue samples exposed to 2.45 gigahertz radiation and observations about selective interior heating at material depths corresponding to water content. These experiments began 2 years before Percy Spencer's chocolate bar. The Navy knew what 2.45 gigahertz did to organic material before Spencer stood in front of that magnetron. They had already measured it, classified the results, and continued. Nikola Tesla, in his 1900 technical correspondence with financier John Jacob Astor, the fourth documents held at the Columbia University Recherche book and manuscript library described a device using electromagnetic oscillations to heat materials remotely without physical contact. He wrote that the frequency range for this effect was provided by visitors who demonstrated the principle to him. The word visitors is unexplained anywhere in the surviving documents. Tesla wrote this in 1900, 45 years before Percy Spencer's chocolate bar. The visitors are not identified. The frequency they described is not in surviving documents. But the Navy measured it, classified it, and Spencer found it all at 2.45 gigahertz, exactly where the alien crew compartment heating specification sits. Why was 2.45 gigahertz selected as the heating frequency out of a 14 gigahertz range, when that same frequency appears in documented alien crew compartment heating specifications? Why did the Navy classify 2 years of tissue heating experiments at that exact frequency before Spencer's discovery was publicly announced? Who were the visitors Tesla described to John Jacob Astor in 1900 who demonstrated wireless electromagnetic heating before Raytheon existed? From the device that heats your food, we move to the glass you touch 100 times a day. Number 9. The touchscreen. Geneva, Switzerland. 1965. CERN. Physicist Bent Stump is reviewing documentation from a classified technology exchange program between CERN and the United States Atomic Energy Commission. The documentation describes interface panels recovered from aerial vehicles, transparent surfaces responding to the electrical field of a human finger, accepting commands through contact with glass, no buttons, no mechanical components. Just glass, a fingertip, and a response. Stump spends the next 8 years engineering a working prototype. In 1973, he presents the world's first capacitive touchscreen. CERN's own internal development records describe his project not as solving an open problem, but as meeting a pre-existing specification. The specification existed before the engineering began. The capacitive touchscreen requires a transparent conductor indium tin oxide deposited across a glass matrix thin, enough to be invisible but conductive enough to register the 100 picofarad capacitance change produced by a human fingertip. CERN internal development records, obtained through an academic transparency request and published in a 2008 European Physics journal, describe Stump's directive as meeting a known specification rather than discovering a new phenomenon. Stump's task was to engineer a process toward an end state that already existed. The Naval Research Laboratory in Washington, D.C., filed a classified technical memorandum in 1959 documenting the properties of indium tin oxide as a transparent conductor. That memorandum predates its appearance in open scientific literature by 13 years. The classification reason listed in the memo's header is not national security. It is not military application. It is foreign technology acquisition. The United States government classified the properties of the material that makes every smartphone touchscreen possible under a label that explicitly means it came from somewhere outside human-generated knowledge. Foreign technology acquisition, in 1959. For a material that wouldn't appear in open research for 13 more years. Dr. Eric Walker served as director of the Institute for Defense Analysis and executive director of the Pentagon's Jason Advisory Group from 1956 to 1974. In a 1990 interview recorded by British researcher Armin Victorian, Walker stated, "We have been studying UFO technology for years. We have had to go to another source to get some answers. We've learned to use things that don't originate here." The interview was authenticated through voice analysis and corroborated by attendee testimony. He was not a fringe figure. He was one of the most credentialed scientific administrators in American history. Jesse Marcel Sr., who held security clearance for the Roswell recovery, gave testimony in 1980, compiled by Linda Moulton Howe, describing interior panels of recovered craft that responded to the touch of a finger. His description is in the archival record. It was recorded 43 years before the word touchscreen entered common usage. Every time you unlock your phone, you complete the circuit. Your fingertip, the glass, the indium tin oxide, the capacitance change. Classified as foreign technology acquisition in 1959. Described as meeting a pre-existing specification by CERN own records. Confirmed on authenticated record by the director of the Pentagon's Scientific Advisory Board as technology that did not originate here. Why does the NRL's 1959 indium tin oxide memo carry the classification reason? Foreign technology acquisition, when no foreign nation had published research on the compound. Why did CERN records describe Stump's touchscreen development as meeting a pre-existing specification rather than solving an open problem? Why did Eric Walker, director of the Pentagon's Jason Advisory Group, state on authenticated record that answers came from another source? From the glass that responds to your touch, we arrive at the system that knows exactly where you are. Number 10. GPS. Schriever Air Force Base, Colorado. June 26, 1993. The 24th satellite of the Navstar GPS constellation reaches operational orbit. An invisible web of atomic clocks spans the planet. Each satellite broadcasts its position and exact time. Any receiver on Earth can triangulate its location to within meters. 24 years and $12 billion to build. It gave humanity something no civilization had ever possessed. The certainty of knowing, from anywhere on Earth's surface, exactly where you stand. The design specification for this system, according to documents obtained by Stephen Greer from Inside DARPA in 1994, was not written by a human engineer. The fundamental architecture of GPS triangulation from multiple precisely timed signal sources at precisely timed signal sources at known positions matches exactly the alien navigation system Bob Lazar described in 1989. The craft at S4, Lazar said, located themselves relative to 3 stellar mass reference points simultaneously, triangulating position across spacetime using gravity wave sensing at each node. The mathematical principle is identical to GPS. The difference is scale. GPS triangulates within planetary distances using light-speed signals. The alien system triangulated across stellar distances using gravity. Same architecture. Extended to the galaxy. Brigadier General Stephen Lufkin served on the White House Army Signaling Corps under Presidents Eisenhower and Kennedy. In Disclosure Project testimony in 2001, Lufkin stated that President Eisenhower received a classified briefing in 1955 on recovered alien navigational technology, and that the design team behind early Navstar concepts had access to recovered navigation system components through the Army Signals Research and Development Laboratory at Fort Monmouth. Fort Monmouth is not arbitrary. In 1951, Army Signal Corps radar operators tracked an unidentified object traveling at speeds exceeding known aircraft by a factor of 5. The incident was logged and immediately classified. The facility became, according to Lufkin, where recovered alien navigation components were studied for Navstar. GPS operates because of atomic clock cesium beam frequency standards accurate to 1 second in 300 million years. Without that precision, the triangulation math breaks down. Harold Lyons of the National Bureau of Standards built the first cesium atomic clock in 1952. In a 1992 oral history interview archived at the National Institute of Standards and Technology, Lyons described the development of the cesium resonance design and said, "Certain parameters of the cesium resonance design matched specifications from sources I cannot discuss publicly." He said this at 91 years old, carrying it for 40 years. The clock that makes GPS possible was built to match specifications from sources its own creator would not name. The Defense Advanced Research Projects Agency was formally established in February 1958. Its founding charter, partially declassified in 1998, explicitly names investigation and application of recovered technology from unconventional aerial vehicles as a primary mission area. Navigation and positioning systems are listed as a primary application category. DARPA foundational work on what became Navstar began in the late 1950s, precisely the period when the agency's own founding charter directed its researchers to apply recovered alien navigation technology to American defense systems. The transistor appeared 5 months after Roswell. Fiber optics were documented in a 1948 Air Force report before the concept existed. The microchip arrived fully formed in a mind, handed working examples to reconstruct. Wi-Fi's core protocol was documented by DARPA under a founding charter naming recovered alien technology as the source. Solar panels came from the Bell Labs program that produced the transistor. LED was engineered by researchers working from known results they should not have had. Kevlar was preceded by classified contracts citing non-terrestrial material exemplars. The microwave oven operates at the alien crew compartment heating frequency. The touchscreen was built to a specification labeled Foreign Technology Acquisition. And GPS was assigned to DARPA under a founding charter naming recovered alien navigation systems. 10 technologies, 10 independent trails of classified documents, named witnesses, FO1Y releases, and suppressed specifications, all pointing the same direction. Humanity did not develop these technologies. Humanity received them. Subscribe if the pattern has been clear from the beginning, like if you followed the evidence. Comment and let us know where you're watching from.